Hello everyone, this is Rohan Meshram. Welcome back to my YouTube channel Scribbles in Bioinformatics. And today I am here to demonstrate you one of the new softwares that I have developed in my lab. And this software we call it as BFEER, and it can be used for calculating free energies using MMPBSA and linear interaction energy. So this is the second video in my playlist. So if you have ended up over here, I would advise you that you watch the first video wherein I have already explained how do you download this software, how do you install this software. So this video, my friends, is for demonstrating the utility of BFEER software for calculating MMPBSA for a protein ligand system that has been simulated with NAMD as a simulation engine. So the example that we are going to use in this particular demonstration is from the recent paper that we have published in Nature Scientific Report. We would be dealing with system of NSP3 microdomain of SARS-CoV-2 virus that we simulated in complex with various pyrazoline analogs. So if you want to know more details of the system, you can view this paper. Okay, so to start with, you would need topology file that is usually given in form of PSA file. You would need the trajectory file that will contain the frames of your system. So what we have done is that we have conducted this simulation for 100 nanosecond, but for the sake of simplicity and saving space, I will be distributing the simulation of last 10 frame so that it becomes easier for demonstration purpose. So along with the PSA file, you would need trajectory file, and you would need all the parameter files that you have used in your simulation. So this file corresponds to the parameter file for protein, and this another PRM file corresponds to the parameter of the ligand that we have used. So this is all what is needed to perform your MMPBSA calculation. So let us start out. Let us load our topology file in VMD. So once your topology file is loaded, all you have to do is to load the trajectory information or the frames that you have in your trajectory. So I am just loading whatever frames that I have in my TCD file, and hence hit this load button. So as you can see, there are 10 frames. So usually when you will perform this MMPBSA calculation, there would be like 1000 frames or maybe 2000 frames. So MMPBSA calculation are usually performed on the last few hundred frames, but for the sake of simplicity, we will be performing the MMPBSA calculation on the last 5 frames in order to complete this tutorial in short time. So let us begin. Our BFEER software is located in the extension menu of VMD. If you select this analysis, and if you have already installed the software properly, it will appear over here in extension analysis, and there would be a link for BFEER. So this is the BFEER's main page, and in this BFEER main page, we provide the calculation type for MMPBSA and LI, but this calculation type will only get activated once you have selected the working directory. So first thing that you need to do is to select the working directory. So working directory can be selected just by browsing, right? So all you can do is that here is where our files are there. All you need to do is to select the path of this working directory. I have copied this path, and all you have to do is to paste it over here and select OK. Now once the path of the working directory is selected, you can now select what kind of calculation you are supposed to do. So let us select this MMPBSA. So once you select this MMPBSA, now in file selection menu, you are supposed to select the topology file that is usually provided in the form of PSF file. Select your PSF file over here. Select your trajectory file over here. This is a DCD file. As you can see, this is a DCD file. Now you are supposed to load all the parameters that you have used in your simulation. So you can use this control button for selecting multiple parameter file. Select those parameter files, hit open, and then you are supposed to provide the name in which your MMPBSA results will be saved. Let us save it as with this name MMPBSA.log. It will create a .log file and it will save all the results in that log file. It becomes convenient that way. Okay, next what you have to do is to you have to tell this software as to you would have to define the complex, the receptor and the ligand. Now how is that you would do that? It is quite really very simple. All you have to do is to go to graphics and representation, and any valid selection will work over here. So let me just give you one example that let us uh, select segname for example. Well, now I know that my protein is present in form of segment B and my ligand is in form of segment called as Lig. So we can select both over here and this will correspond to our complex. All you have to do is to select this. I am copying it by pressing Ctrl C and paste it over here. So what this line says is that your complex in your system is comprised of the segment with name B and segment with name Lig. Lig is your ligand. So receptor would be segment with name B and ligand will be the segment with name Lig. So you can use any valid selection, VMD valid selection over here, that will work. We have designed the software in that way. Okay, so now there are 10 frames as you can see over here. We would be performing calculation on last 5 frame. So the first frame would be the maybe 6th frame and the last frame would be the 10th frame. In VMD, the frame number starts with 0. So all you have to do now is to click this run calculation button, and the progress can also be monitored through the VMD TK console. I will open this VMD TK console and you can monitor the progress as to what the software is doing all the while. So all you have to do now is to hit this run calculation button. It will show a progress bar over here by which you can determine as to what is the progress of our calculation. So far so good. Currently it is running the PB calculation, Poisson-Boltzmann solvation model that we have implemented using the APBS software. So it will take some time for this PB calculation. It has already conducted this MM calculation and it says that it took around 4 seconds to do that. So PB calculation is a bit of time consuming task. So last time I did this test run, it took me about a single minute. So we might want to wait for a while, maybe 1 minute or so. So maybe I will pause my recording. Okay, once the calculation is finished, it will show another dialog box stating that calculation completed successfully and you are done with this. Just hit this OK button. Now you can see in this VMD TK console that for this calculation it took about 2 minutes and 1 second. So the time that will be taken to complete your calculation will completely depend on the version of the VMD that you are using. Currently I am using some older version 1.9.2 for this demonstration. It will also depend on the number of frames that you have decided for calculation, as well as the size of your system might be also one of the limiting factors. So considering all these variables, it might take some time. So you might have to be patient when the calculation are in progress. So in this VMD console itself, it will give the final calculated free energy value that over here it says that the free energy calculated is minus 6.3 kilocalories per mole. Okay, so now once this is done, the calculation is also stored in a separate log file called as MMPBSA.log. That is what the name that we have given. You can open it in any text editor. Here is the detailed you can say contribution of various component that we have calculated in MMPBSA calculation, and there is a summary over here. This total energy from delta section is what you are looking for, and this is what is reported in VMDTK console. So there will be a separate video wherein I will break down what is the content of this log file, but for time being, for demonstration purpose, this is how you use BFEER for MMPBSA calculation. Thank you guys. Next video for LIE calculation.